Hello, I'm Jim Schaefer, the producer and host of Riprap, the academic book television program. My guest today is Mark Monmonier, who's here to discuss his book, Heir Apparent, How Meteorologists Learn to Map, Predict, and Dramatize Weather. What a wonderful book, and what a title. It caught my eye right away, Heir Apparent. What led you, a scholar who taught cartography of landforms, to take on one of the most popular kinds of maps in our popular culture, the weather map, which has to be known just by every person in this country because they see it at least once a day on the evening news or from time to time during 24 hours on the Weather Channel. How did you get into this topic for a book?
Well, Jim, it started back in the mid-1980s when I was looking at another kind of popular map, newspaper maps in general. And I was sampling newspapers, I was interviewing journalists, I was trying to find out whatever I could from a relatively meager literature. But one thing I noticed is that there was a certain point in which newspapers started running weather maps, but it tended to be irregular. So I looked into this a little bit more carefully, and in fact I found that this was an interesting little side research project, and I in fact did a paper on this that was presented at the International Society for the History of Cartography. This led me to think that there might be a possible book here, but that idea was shelved, and I came back to it about 4 years ago while I was working on a book concerned with the geography of hazard maps, or with the use of maps, let's say, to represent the geography of hazards. I find that there's a lot really that cartographers can learn when they look at with different kinds of maps, and certainly in academia, those of us who teach cartography are, I suppose, concerned principally with teaching students how to design maps. But in this day and age, where there really is such a great variety of different kinds of maps out there, more and more of us seem to be turning toward studying how maps are used. And when weather maps obviously make an obvious focus, because as you say, these are used extremely widely, certainly in television, also in newspapers, and their history makes a fascinating story.
Well, one of the things that fascinated me was that there were maps in newspapers that early, you know, 1912, and then there was also in the 1890s. Can you tell me how they produced those? I mean, that was just extraordinary. I thought, well, how could they do that? You know, these days we know we have electronic technology, but how did they come up with maps in 1912 or 1890s?
Well, in 1912, that's an interesting part of the story because that was the time in which the U.S. Weather Bureau, which was producing weather maps in over 80 different weather stations. They were trying to save money, and when more than half of these weather stations, they also employed printers. And weather maps were an important part of their operation, and they were concerned not just in using these to produce local forecasts, but also in being able to publicize the activities of their group, of their bureau, to create interest. And they found that they could reach a much larger audience. They could improve their circulation, as it were, if they were to enlist newspapers in publicizing their work. What they had to do, however, in order to convince news publishers to run these, was to provide them with artwork that was timely, and that the newspapers could also very easily integrate with their own printing operations. So they provided newspapers with either a printing plate, which could then be taken to the press plant and locked up with type on other artwork, or with a very, very sharp black and white copy, which newspapers use for photographic engraving.
How did they get the information to put together these weather maps in those early years?
Well, they had a process. It was a very large organization employing well over 1,000 people. They had for observers throughout the country. They had a routine where they would collect observations twice a day, 8 o'clock in the morning and 8 o'clock at night. The information was then telegraphed to Washington, and well, several things happened. One of these things was that the information, some of it, not all of their observations, were actually telegraphed back to local Weather Bureau stations, where they had one person who would take some of these data and actually plot out a weather map. And these weather maps were used to provide information for local newspapers. They were also posted prominently. And in fact, the Weather Bureau at that time, where they had their own printing operation, they also depended quite heavily on the U.S. mail, because we were talking about a time in which some cities had 2 or 3 mail deliveries per day, so the information could get out when it was still rather timely. But what was especially important was to get the information from a wide variety of different points to a central point rapidly, so it could be put on maps, and then forecasters could take a look at the data as it was plotted. And in fact, in Washington, they had 4 clerks who would produce 5 different kinds of maps, where they would look with temperature and pressure and precipitation on change. And in particular, change was extremely important because they were concerned with trends. And then they would issue a national regional forecast, and in their various stations throughout the U.S., local forecasters would also issue customized forecasts.
Yeah, you mentioned in the book about that blizzard of, what was it, 1898 that killed 400 people,
Right.
but it could have killed a lot more, except that there were these weather maps out forecasting that the storm was coming.
Yeah. That was a classic northeaster, and there was one ship's captain who did not heed the warning, although there seems to be some controversy as to why, in fact, he sailed. One story has it that he would prefer to have stayed in port, but he had been disciplined by the ship's owners. To be that as it may, he left port in a time when there was a very serious storm, and basically his ship went down, and all of his crew and passengers. I think this is an excellent illustration, not only for us, but certainly for the people at the time, of the fact that weather maps were extremely useful when warning people. Now, what was important here was that they were able to get the warning out, and that this warning was believed, at least by most people. You can have problems these days, let's say, with tornado warnings, where getting the warning out can be a problem, because that kind of warning, you might have only something like 10 minutes. And then, of course, you can have a situation where people get the warning, but they maybe don't know what to do, which is to say that sometimes maybe you have trailer parks where they don't have a shelter, or you have areas, let's say, where people don't have basement.
And a very brief amount of time to react.
That's right.
But still, this blizzard was 100 years ago, and that's what I found very interesting. But the other point in your book is that going from the point of what was going on then until now took a certain blend of science and technology, bureaucracy and cartography, all working together to produce better weather maps. Can you talk a little bit how that interaction worked as the science evolved?
Well, the cartography almost was an afterthought. The first weather map that anybody has been able to figure out was made about 1816 by a German physicist by the name of Heinrich Wilhelm Brandis. And Brandis apparently had some sense, maybe because of his training in physics, that there was a broad regional relationship between atmospheric pressure and wind. Now, they were able to measure atmospheric pressure because the barometer had been invented more than 100 years earlier. Brandis took some data, but these data were 35 years old. They were collected by the Meteorological Society of the Palatinate, which was a German organization, which had a network of observers throughout Europe. And they had been collecting information for quite a few years, but they never did anything with it. They were using it because they thought that there might possibly be some relationship, let's say, with local plant growth or with sun cycles or things like this. And it was only when Brandis came along that people began to realize that you can take these data, put them on a map, and maybe get something meaningful out of them. Brandis' original map was lost. Some people have doubted whether he actually drew it, but there's a fairly good description by him of what he did and what he saw and what he reasoned. So even though that artifact was nowhere to be found, it seems to be quite plausible that he was really the first person who ever really mapped weather. This led in the 1820s and 1830s to a controversy over the nature of storms. And meteorologists, or well, we actually didn't have meteorologists back then. These were oftentimes talented amateurs, known these days as natural philosophers. But they were making maps, and some of them set up fairly extensive correspondence networks for the Postal Service to collect information collected by observers using standardized instruments. And the information at that time wasn't timely. But what they were able to do was to not only verify Brandis's observation that there is a relationship between wind and pressure, but also to work up a primitive theory. Well, the problem was, of course, they had not just one theory, but two. There was a theory that you had wind moving inward toward the center of a low-pressure cell. And there was also a theory that you had a circular counterclockwise motion around the center of a low-pressure cell. And at least with maps, of course, one could start by simply mapping where you had low-pressure cells. But these primitive notions of storms, as people argued about it more and more, one of the things that they realized is that by and large both theories were actually right. And as it turned out later on, neither theory was completely right, but that's the later part of the story. What people began to realize is that if they were able to get these data in one place rapidly, simultaneous data, observations taken at the same time, or assembled in one place, and if they could do this quickly, they could make maps that could be useful as a forecasting tool. When the electric telegraph became commercially viable around 1845, some people realized that there is the possibility here of being able to forecast weather. But it took a long time. And in fact, in this country, it took until about 1870, actually the late 1869s, when an amateur named Cleveland Abbe tried to set his own weather service. He really didn't have very many observers, but he had the rather tenuous cooperation of the Western Union Telegraph Company. But this demonstration was enough to convince the federal government that it would be worthwhile for us to have a weather service. So they set this up actually in the Army Signal Service. And in fact, this remained an Army operation for 2 decades until 1891, when the Weather Bureau became a civilian agency within the Department of Agriculture. So we have the telegraph, we have the sense that we can make maps, and we had to have an enormous bureaucracy where you would have people, and they realized that they were not able to rely principally on volunteers. Where you had people who would be able to play 2 roles. One, to collect data, and the other one to generate local forecasts. What they also realized was that there was this relationship between low-pressure cells and storms. And they began to make lots and lots of maps so they could actually track the movement from west to east of low-pressure cells. And at that time, they were spending a lot of time and effort on also making not only weather maps, but also storm track maps. That was the principal meteorological theory at that time. Weather maps became very important in training people to become meteorologists, or at least forecasters. If somebody wanted to learn how to forecast weather, they didn't study meteorological theory. Well, I guess they obviously did, but it was a relatively rudimentary theory. They obviously didn't have to study calculus or even much physics. But what they had to do was to spend lots of time looking at huge books of weather maps published by the U.S. Weather Bureau, and they could see the development of storms, the movement of storms, and the ultimate dying out of storms. And this basically was how forecasters operate. It was very much almost a kind of seat-of-the-pants operation.
Did you see an evolution in terms of cartography of the kinds of symbols and the sophistication of how the information that they had was evolving? Or, you know, like the different ways it was indicated, like you were saying, they were watching for the storms. Did you have a chance to take a look at that part of it? Or?
Well, I looked, I guess, at several things. One is that weather maps for a long time have used isolines. And these are lines which are sort of like elevation contours, except they represent a constant value on a surface. And you can have a pressure surface, which is to say that you have a map. In theory, at least, you know, one can measure atmospheric pressure anywhere. And in theory, too, if you had a lot of measurements, you probably would have maybe a relatively gentle surface, which is to say that there would be some areas in the surface where you would have a low-pressure cell, a low-pressure center, sort of a kind of a pit. There would be other places in the surface where you would have a peak, which would be a high-pressure cell. And we could also have, let's say, maps concerned with temperature. Isolines were used very early on. They also had point symbols, which represented observations at specific points with weather stations, and they would generally use relatively simple arrows indicating the direction in which the wind was moving. They also used circular symbols, and if the circle was completely darkened, it indicated clouds. If it were partially darkened, partly cloudy, if it were clear, this would be clear weather. They also used alphabetical symbols, R to represent rain, S to represent snow. And because they had lots of people using different kinds of, because they had lots of people working with them, using weather maps for different cities, this standardized symbology just seemed to come about. In one part of the book, I also looked at some efforts, principally around the 1930s. Well, even there were earlier efforts in the 1890s to try to have internationally standardized weather symbols. And there was some movement toward that, but even with international standards, most countries generally had a few symbols that seemed to be customized for their own operation. Weather maps were also useful, by the way, in a kind of international intellectual commerce where scientists and forecasters would exchange maps because obviously somebody who was trying to learn how to become a forecaster over here might also benefit by looking at some of the experiences in Europe.
I noticed also in the book that there were several interesting devices that emerged as people, you know, the early warning system by the Dutch government, and what was it, the Marvin Hargrave kite and meteorograph, and the pilot balloon stations, and radar, and geostationary satellites. It's quite interesting, the stories that those have.
Well, a big part of the story is that meteorologists, who always have been very good in trying to innovate as well as make do, realized that what you can get from just mapping surface weather was not enough. The atmosphere itself is thick. It goes up, it goes up, in some ways one wants to look at relatively thin air, more than 100 miles. But for all practical purposes, let's say in air latitude, its thickness might be of the order of 5, 6, or 7 miles. But sampling the upper part of the atmosphere was tricky. This was worthwhile because there obviously are wind currents up there, which are very important when moving cold air, warm air, moisture-laden air into an area. And if one really wants to understand what's going on, if one really wants to be able to forecast, you have to be able to map more than what is just happening at the surface. So they tried to probe the upper atmosphere, and some of the primitive devices that they had early on were almost, I wouldn't say laughable, but I guess, you know, probably an indication of just the recognition that there was something important up there that they had to get at. And secondly, they would use, you know, whatever they thought was, whatever they thought might work. One of the things that they used were huge box kites, not the normal kind of kite, which might be, you know, 3 or 4 feet long, but these were huge things, taller than an average person. And they had to be large because they wanted to be able to lift up in you know, 1, 2, perhaps maybe 3 miles, meteorological instruments. Now, even though these were downsized, they had to get their data back, and they recorded their measurements on a circular rotating drum operated by a clock mechanism with some pens. This was the meteorograph. And in order to raise these up, well, one of the things that the Weather Bureau did was to set up a research station down in Virginia, I think about 50 miles out of Washington, in an area called Mount Weather, an area that was relatively high, and they were able to loft these kites in the air with several miles of relatively thin but very strong piano wire. Later on, they also tried balloons, which in some cases they had free floating ones, so that they could observe them with telescopes, which were also able to measure the changing elevation angle, so they could observe how rapidly they were rising and to what height, and how rapidly they were moving. In the 1920s, with further developments of wireless technology, they were able to put radio transmitters on these, when radiosondes were extremely useful at one point. But once again, this was a very expensive operation. When airplanes came along, and commercial aviation was practicable in the late 1920s, early 1930s, when we had airmail, the Weather Bureau collaborated with the Department of Commerce in setting up certain corridors, certain routes which would be used by airmail planes as well as by people who might be traveling by plane. And they had special weather stations along these routes. And in fact, aviation was a significant lobby for improvements in the U.S. Weather Bureau. Which brings us to another story. The Norwegians were extremely able, extremely adept in their forecasting, because they had to compensate for the fact that they were a coastal nation, and they really didn't have this huge database that we had. They had some observations, let's say, which were radioed in by ships at sea, and they tried to compensate for this by our theory. And their theory, which ultimately in the 1930s was accepted by the U.S. Weather Bureau, their theory of cyclogenesis was an extremely important contribution to meteorology. This was a theory that allowed people to use surface weather observations and to sort of maybe extrapolate a little bit more as to what might be going on. The atmosphere itself, or let's say storms, are almost like giant mixers. We have relatively warm, moist air which is coming out of the tropics, and this meets relatively cooler, usually drier air coming downward from the polar areas. This creates something which is recognized as the polar front. And along this polar front, storms typically form. Storms are not just low-pressure cells, but storms also seem to be comprised of two principal fronts. There's a cold front as you have cooler, generally drier air sort of moving southward, and there's also a warm front as you have warmer, oftentimes moister air moving northward. And these two fronts tend to meet at the center of the low-pressure cell, and they tend to sort of move around each other in a counterclockwise motion. And this theory dominated forecasting for quite some time. Ironically, or perhaps maybe understandably, because the U.S. Weather Bureau was a huge organization, and organizations tend to have their leaders, they tend to have their own ways of doing things. There was a resistance here for the adoption of this theory of cyclogenesis that came out of the Bergen School of Meteorology. This changed during the 1930s when the Weather Bureau had a number of disastrous forecasts, and there was a significant shakeup, and there was a recognition, at least by some of the sharper people there, that there was a scientific theory here that was not just theory, but it also worked. Now, what's happening these days? This theory is just, well, part of it. Nowadays, we have not only radar, which is able to sort of see outward and actually look around weather stations. We also have satellites, geostationary satellites, usually positioned in an orbit over the equator, where they're there day and night.
What did you mean by the title Heir Apparent?
I like puns. But this is a pun which really works, because I think one thing which is very basic to weather maps is that we take measurements of things that by and large we're not able to see. Typical cartographic products, show land use, which you can go out and look at, or they show elevation, where you can see that there's a hill here and a valley here. Meteorological data principally involve pressure, which you have to measure, temperature, which you have to measure, wind speed, which you have to measure, and so forth. And what these maps do is to take something which is not